In section 7.5, we're going to introduce another strategy called the elimination method to help us solve linear systems. Say we're asked to solve the following linear system. If we're going to use the method of elimination, we always want to line up our linear system so that our x terms line up under our x's, our y's under our y's, our equal signs, and our constants. Now, right now, if we were to multiply or add going vertically, nothing would really eliminate because x plus x would give me 2x, 2y plus y would give me 3y, and 10 plus 7 would give me 17. However, if I multiplied the bottom row by -1, this would become negative, this would become negative, and this would become negative. Now, if I added up my columns vertically, x minus x disappears, 2y minus 1y is y, and 10 minus 7 is 3. So I found my first coordinate of my solution to be y equals 3. To find the next coordinate, to find x, we can use either of our initial equations. So our first equation with x plus 2y equals 10. And then I'm going to substitute 3 in for y. So I get x plus 6 is equal to 10. If I subtract 6, I get x is equal to 4. So my solution would be the point 43. So on a scale of difficulty, this question would be quite simple because all I had to do was multiply my second row by a negative, and then I was able to eliminate one of my variables. In the next example, if we take a look here, I have 3x minus 4y equals 7, 5x minus 6y equals 8. And again, if I was to add these up, nothing would eliminate. None of the coefficients in front of my x or my y's are the same. So I have to be a little bit creative here. So with this question, I'm going to try and get the same number in front of my x term and the opposite same number in front of the x term in the second equation. So to do so, I'm going to multiply the top row by 5 and the bottom row by -3. And if you notice, 5 is the term in front of the x term in equation 2, and 3 is the term in front of my x term in equation 1. So if I multiply by 5, I get 15x minus 20y equals 35. If I multiply by -3, I get negative 15x plus 18y equals negative 24. Now if I add these up, you'll see that the x's eliminate, and I'll be left with negative 2y is equal to, and I'm left with 35 take away 24, which is going to be 11. Now, if I divide both sides by -2, I get my y coordinate to be negative 11 over 2. Now to find, to find the x, and I go back and I have 3x minus 4y is equal to 7. And again, you can use either equation. I chose to use the first one. So 3x 4 times negative 11 over 2 is equal to 7. So 3x, this becomes 44 over 2, which becomes 22 equals 7. So I get 3x is going to be equal to 7 subtract 22 is negative 15. If I divide both sides by 3, I get x is negative 5. So my solution is going to be negative 5 and negative 11 over 2. So again, in this example, I have to multiply both equations by a constant in order to get a coefficient in front of one of the variables to be the same so that they would eliminate. Okay, I would like you to pause the video and give this one a try. Okay, looking at this example, you notice that I have 7y and a negative 2y, or I have a 2x and a 3x. Because I have a positive and a negative, I'm going to deal with the y's here, and I'm going to multiply the top row by 2 and the bottom row by 7. So I'm going to end up getting 4x plus 14y equals 48. And if I times 2 by 7, I get 21x minus 14y equals negative 28. So adding these up, I get 25x. The y's cancel, and I'm going to have 48 take away negative 28, and that's going to end up being 20. If I divide both sides by 25, I get x is 20 over 25, which reduces to 4/5. So now I have my first this coordinate. I have my x value, so now I need to find my y coordinate. And to do that, I can substitute back into either of the equations. So let's take the first one. So I have 2x plus 7y is equal to 24. So I'm going to have 2 times 4/5 plus 7y is equal to 24. So I end up with 8/5 plus 7y is equal to 24. Now, there's a couple ways you could solve this, but let's multiply through by 5 to get rid of my fraction. And if I do that, I'm going to end up with 8 plus 35y is going to equal 24 times 5 is going to give me 120. And now I'm going to subtract the 8 to the other side. So I'm going to get 35y is 112. And then I'm going to divide both sides by 112. Oops, sorry, not by 112, I'm going the other way. I'm going to divide both sides by 35. Therefore, my final answer is going to be y equals 112 over 35. So my solution is going to be 4/5 and 112 over 35. And that would be your final answer. Okay, now you could reduce 112 over 35 to be 16 over 5. So that would probably be the way the answer would be written in the back of the book. Okay, in our last example, we've seen one like this when we did section 7.4. Again, we want to get rid of our fractions first. So to do that, I'm going to multiply everything through by 6. And here I'm going to multiply everything through by 4. So if I multiply the 2/3 by 6, I get 12 over 3, which is going to be 4x minus 3y, and that equals 24. And this is going to give me 2x plus y is equal to 10. So now you notice I have a y and a negative 3y. So if I multiply the bottom row by 3, I'm going to get, I'll just put the equation up here, I'll get 6x plus 3y is equal to 30. Then I'll bring down the first one, which was 4x minus 3y equals 24. So if I add these up, I get 10x. 3y's cancel, and this is going to equal 54. And divide both sides by 10, and I get x is 54 over 10. So x is going to be 27 over 5. So now you could plug back into the original, but then you're using fractions, or you could plug right back into either of these right here. So I'm going to choose this one. I'm going to use this one here because it's a little bit smaller. So to find y, I'm going to use the equation 2x plus y equals 10. And my coordinate is 27 over 5. So it's going to be 2 times 27 over 5 plus y is equal to 10. So this ends up being 54 over 5 plus y is equal to 10. Again, I'll multiply everything by 5, get 54 plus 5y is equal to 50. If I subtract 54 over, I get -4. And if I divide, I get y to be negative 4/5. So my answer is 27 over 5 and negative 4 over 5. Okay, there's a couple of questions for you to try on the elimination method. Again, another strategy, different than the substitution, but again, you end up getting the same answer no matter what method you choose.